So dear students, welcome to this lecture on textile testing. In this lecture, I will cover two fabric properties. One is the drape, another one is the thickness. Perhaps uh, most of you have already carried out the practicals on this measurement of drape and the thickness of the fabric. Here we will discuss what is the theory behind the measurement and the measurement process. So let us first see what is the meaning of the word drape. Drape is the term used to describe the way a fabric hangs under its own weight. Suppose you hang the fabric, okay, and allow it to fall. Now what will happen? The fabric will appear in some graceful folds. Now draping quality requirement of the fabric depending on its end use. Therefore, a given value of drape cannot be classified as either good or bad. What I mean to say here is that draping quality is not an essential fabric property. In some cases, it is considered as desired, and in other classes, it is not required. So let us see. Drape is important in applications like curtains, tablecloth, and women's clothing. Women's fabrics are woven fabrics are relatively stiff when compared with the knitted fabrics. See, the knitted fabric always take the shape of the contour of the body. Now, drape is quantitatively measured in terms of drape coefficient, and a lower value means the fabric is softer and its drapeability is better. In other words, higher drape coefficient means stiffer the fabric. What I mean to say here is stiffness and drape, these two are very much interrelated. If the drape coefficient is high, you can say the fabric is stiffer. On the other hand, if the drape coefficient is low, the stiffness is also less. Now, let us see what is the measurement procedure. Now, to determine the drape coefficient, we need at least two specimens, and we have to test the fabrics in both ways. In the test, a circular specimen is held concentrically between the two small horizontal discs and is allowed to drape into folds under its own weight. The shadow of the fabric, due to the light source underneath, cast is stressed into the piece of the paper of the same size as the unsupported part on the fabric specimen. So here you can say that this is the sample. This is the sample. This sample is mounted between two concentric rings or two clamps. Okay, and below this there is a parabolic mirror, and light is reflected from this parabolic mirror and create an image onto the paper ring. Now this is the type of the image that is formed. So this is the folds that appears in the fabric when it is allowed to hang vertically. Now specimen deforms in the multi-directional curvature. See, these are the multi-directional curvature, and depending upon the shear properties, bending stiffness of the fabric. That means, as I've already told, the drape coefficient as well as the appearance of the fabric while it is allowed to fall vertically, it depends upon the bending stiffness as well as the shear rigidity of the fabric. The higher the drape coefficient of the fabric, stiffer is the fabric. Now, this is the experimental setup. The sample is mounted between the two rings. This is the light source, and this is the parabolic mirror. The light coming out from the source will reflect it from this parabolic mirror, and therefore it will create a shadow onto this paper ring. You can see that I have mentioned the same thing. In the actual case, the light will cast a shadow on the draped fabric onto a ring highly uniform translucent paper supported on a glass screen. See, this is the paper ring. The surface drape pattern area under the paper ring is directly proportional to the mass of that area. To measure the areas involved, the whole paper ring is weighed and then the shadow part of the ring is cut away and weighed. The paper is assumed to have constant mass per unit area so that the measured mass is proportional. Okay, now perhaps you can recall when you did the practical, you have measured not the area but the mass. Why it is so? Because see, the area is very difficult to measure. Why? Because this area is irregular in shape. This area is very irregular in shape and you cannot determine the area very easily. That's why instead of measuring this area, you will measure the weight, because I have considered that the weight of the paper and the area are proportional to each other. Now, drip coefficient is defined as the mass of the shaded area divided by total mass of the paper ring. Okay, and sometimes it is expressed in terms of 100. Now, remember the drape coefficient value of maximum value of the drape coefficient will be 1. It cannot be more than 1. Now, when the value of the drape coefficient is 1, it is the very stiff material. It cannot be 1 for a very textile material or in a woven or knitted fabric. It can be 1 just like a rigid body like gramophone record, or you can say a piece board, or you can say cardboard, etc. In that case, mass of the shaded area will be equal to the total mass of the ring. In fact, these two mass will be identical. Okay, so maximum value of the drape coefficient is 1, or when it is expressed in terms of percentage, it is 100%. Now, one thing that you should know regarding the drape coefficient, that it has got no unit. Why? Because either it is the ratio of the two areas or it is the ratio of the two masses. Okay, that's why it is dimension. Now, second part, here I will discuss the fabric thickness testing. This test also we have carried out in practical. Now, fabric thickness, I need not to define what is the meaning of the word thickness, but thickness of the fabric is played a very important role in determining some of its characteristics. The first thing is it will determine the warmth of the fabric. It will determine the air and the moisture vapor permeability of the fabric. It also determines the stiffness and the rigidity of the fabric. Okay. Now you can see that always in the winter, the thickness of the fabric is always good. Why it is so? Because higher the thickness of the fabric, more will be the amount of air that is enclosed by within the fabric. Okay, that's why. And higher the volume of the air that is enclosed within the fabric, more will be the insulation property. That means air is a very good insulator and it will not allow the fabric to transmit the body heat to the outside. That means what I mean to say is that the higher the fabric thickness, more is the warmth produced by the fabric. Now, one thing, that is the textile materials, it is very compressible in nature. That means its thickness will always vary with respect to pressure. That means if we apply more pressure, the textile material will be compressed and it will show its less thickness. That's why for the practical purpose, the thickness measurement are rarely used as they are very sensitive, and only we use the grams per square meter, or you can say the weight per unit area. The most common unit of the weight per unit area is grams per square meter. Now let us see, when we apply the compression load onto the fabric, how the fabric will behave. Naturally, the fabric will deform. Now, the deformation of the fabric will take place in 3 different stages. The firstly, the individual fabric properties, the individual fibers protruding from the surface are compressed first, and the bending of the fibers provides the resistance to bending. That means if we apply the compressive load onto the fabric, first the individual fibers which is coming out from the surface of the body, they will first compress. See, this is the fabric, and this is the fibers which are protruding from the surface of the fabric. So when the load is applied first, these fibers will undergo bending. And secondly, the contact is made with the surface of the yarn. Now, if you go on increasing the load, then what will happen? This body surface fibers will completely bend, and the yarn will uh, come in contact, and they try to flatten and displace at this stage. That means when you apply more and more pressure, now the contact is made with the surface of the yarn, and the yarn tends to flatten. The moment the yarn tends to flatten, the what are the other neighboring yarns and the fibers, they will oppose the flattening. And in the third stage, the resistance is provided by the compressional resistance of the fibers themselves. That means right now the fibers will undergo compression, and they will try to oppose the bending. Now this is the variation of thickness with respect to the pressure. Here you can see, if we are go on increasing the load, the thickness is decreasing. But if you see this curve, here we are gradually removing the load, and you can see the thickness is always increasing. But there is always an hysteresis effect. What is the meaning of the term hysteresis effect? At any pressure, you can say, I can consider the 10 kilopascal pressure. You can see there is a variation in thickness. When we are loading the we are increasing the load, and when we are reducing the load. See, when we are increasing the load, the value of the thickness is at this pressure, that is 10 kilopascal pressure. This is the thickness. You can say it is slightly less than 0.6, but when we approach it from unloading side, the thickness is even smaller. This is the hysteresis effect, and this is occurred because of the deformation of the fibers. Now this is the fabric thickness tester. This shows the various parts of the fabric thickness tester. See, the one is the anvil on which the fabric is placed. This is the pressure foot. Different dimensions of different pressure foot are used. There may be 10 millimeter diameter, or sometimes it may be 25 millimeter. Now, this one is a dial gauge. This is the dial gauge from which we can read the thickness. This is the knob for the zero adjustment. Now, this is the weight that we, as per the test standard, we have to apply the load from this side. Okay, this is the lifting lever. That means by means of this lever we can apply the load, or we can relieve the load. And 7 is the screw for the calibration. Sometimes we can calibrate the instrument with respect to standard material or standard thickness. Okay, the range of measurement is 0 to 10 millimeter. The least count of the dial gauge is 0.01 millimeter. Diameter of the anvil is 60 millimeter. Diameter of the pressure foot may be 10 millimeter or 25 millimeter depending upon the requirement. The loading on the pressure foot is 100 grams per square centimeter. Now, let us discuss the work procedure. You have to place the specimen onto the anvil, and the pressure foot is gently lowered onto it. The reading of the thickness is taken at the desired pressure, and the flat circular indenter of the micrometer exerts a specified pressure on the fabric sample. This procedure you have to repeat for three different locations, and the mean value of all the readings of the thickness is determined to the nearest of 0.1 millimeter. So this is all about your measurement of thickness. So remember, regarding the thickness, I would like to say one thing, that is thickness is a variable, and while measuring the thickness, we have to always mention what is the pressure of measurement of the thickness. Higher the pressure, less will be the thickness. Okay, so that's all. So in the next class, I will discuss the fabric shearing property and the rusting strength of the fabric. Okay, best of luck.